Hello guys, am I audible to you?
Yes, sir.
So I think I gave some homework, and if you have some doubts, I will discuss the doubt first, then I'll move towards the theory part.
So I have few doubts on the Erodov.
Yeah. You just tell me the question number.
So the 50th and 56.
56. So you're talking about a body rotates with angular velocity omega equals to AT I cap plus BT square J cap. That one?
Yes, sir.
So omega as a vector is given, and the bold alphabet in Erodov represents vector quantity. So the moduli of angular velocity and the angular acceleration at the moment t equals to 0. So anyway, so at t equals to 10 seconds. So what is the problem with the first part? First part you got the answer?
Yes, sir. The first part I managed to get, but the second one.
The angle between the vectors of the angular velocity and the angular acceleration. See, alpha is defined as how? D omega by dt, isn't it?
Yes.
So you got alpha, I hope so. Like this, yes or no, tell me.
Yes.
Now, when omega is known to you as a function of time t and alpha is known to you as a function of time t, how to find the angle between two vectors? Which product we use? If you remember. So what is mod of omega? So mod of omega is how much? Under root of a square t square plus b square t power 4. And what is mod of alpha? And of course, you can substitute the value to get the answer. I'm writing in general. So it is a square plus 4b square t square. Am I right?
Yes.
And we know that to find the angle between vectors, we should use always the vector product, the dot product of the vector. So we can write omega dot alpha is mod of omega multiplied by mod of alpha into cos theta. So theta is the let's say angle between them, and the dot we can take because both are in the analytic form, the component form. And the dot, we know that the I will go with I, J with J, so it will become A square T plus 2B square T cubed.
Fine, sir. I'll do it.
Yeah, so now rest is you have to substitute in the formula and you get the answer. Okay. Next part.
So the 50th one.
58. Prasansa, how many you tried better?
So the sheet which you gave, I have solved till D section, but I
Okay.
had some doubts in the C section C.
Okay. So I think you're saying 1.58?
So 50. 50.
50. So the question says that a solid body starts rotating about a stationary axis with an angular acceleration of beta. And beta is given by beta naught cos phi. So phi is the angle with some reference line. Find the angular velocity of the body as a function of phi. So this is the angle. How to find the angle of velocity? Tell me. Omega is defined as, by definition, what we should use?
So d phi by dt.
D beta by dt, correct?
Yes, sir.
And if you differentiate, so it's a constant vector. Beta naught is a constant vector, so we can take it out, and we have to only differentiate the, and this will give you B naught, and cos gives minus sine phi into d phi by dt, isn't it? Okay.
Yes, sir.
And the d phi by dt itself is how much? That is the omega itself by definition. Oh, wait. I have made a mistake. This is angular acceleration given. What we are doing there? I thought this is the angle. Anyway, that's easy. That's why it was coming something meaningless. So beta is the angular acceleration given to you. Okay. And you're supposed to find the omega. So how to find omega as a function of angle phi? So angular acceleration we can define as omega d omega by d phi equals to beta naught cos phi. Am I right?
Oh, yes.
And it's a pretty easy, I think. And because beta naught is a constant vector and body starts from rest. So we can say when phi is 0, this is 0 and this is phi, so this is omega. So omega square by 2 is sine phi. And sine phi will give you sine phi. Anyway. And you're supposed to draw the graph, which is sine phi graph. All right, so you can draw the graph of root of sine phi. How the graph of root of sine phi will look like? Any guess? So of course, the root of sine phi is only true from 0 to pi, right? So we should take a kind of mod here, right? Why? Because the omega cannot be negative. Sorry, the sine phi cannot be negative because it is within the square root sign, correct?
Yes.
So it is like a root of sine phi. So mod of sine phi will be like this. First of all, then how to convert into root? Okay. So it will be 0. So taking the root will keep it curve only. Root sine phi. I need to check the root sine phi graph. Something similar, but somewhat different for sure. Okay. Is 2 beta plus minus. Okay. It will repeat the same. From 0 to pi. Oh, no. So this will become omega. It is like this. They have made it like this up to pi. And how they have taken this, because it says a square, so they have taken this actually as omega equals 2 plus minus of, because that is correct also. 2b not sine phi. And from 0 to pi, we know this is something like this. And the minus means you have to just draw the inverted graph for the sun. So this is what they have taken the graph of omega. Anyway, so just remember the graph, that's it. It is similar to the curve line, but because of root, it will become more flattened, because when you take a root something, the value decreases, right? So root of 4 is what, 2. So on a 4 is here, but graph of root 2 will be somewhere here, so it will become more flattened. So actual graph is like this, so it will become more flattened. So in this case,
Fine,
we
sir.
have to do the same thing. We have to make it more flattened than the actual height, and it will look somewhat similar. Anyway, so that you can remember. Okay. But the process was simple. Anyway, next question. Then?
Sir, in Erodo, that's it, these two.
Okay. So I think the questions I was having doubt. Okay, Prasad, so you can send me the question.
So it's from the PDF that you sent.
Just a minute. Either I can open the PDF or I can. Okay, I'll open the PDF. That's okay. So tell me which one.
So exercise 1, part 1, section B, the first one, and section C, first and second.
So a ball is projected making an angle theta with a vertical. So this is the question of projectile motion. Consider a small part of the trajectory near the highest position and take it approximately to be a circular arc. What is the radius of the circle? So you
No,
know
sir,
how to.
not that one. Section C and section B.
Okay, section C. You mean to say C1? Question, tell me question. No?
So section B, the first one, B1, and section C, C1 and C2.
Okay, so B1, C1, C2, right?
Yes, sir.
So a particle moves uniformly in a circle of radius 25 centimeter at 2 revolutions per second. So what does it mean? How much angle you travel per second?
So 4 pi.
So delta theta by delta t is how much? 4 pi radian per second, correct? So omega is known to you as 4 pi radian per second. Okay, all right. And it is moving uniformly. What does it mean? Uniform circular motion means what? Uniform circular motion. So which
Speed
acceleration
is constant.
is speed is constant? Omega is constant, right?
Yes, sir.
So which acceleration will not be there? Which component of acceleration will not be there? There are two types of acceleration in case of circular motion, if you remember.
Yes, so tangential and centripetal.
So which one of the two will not be present in this case, in case of uniform motion?
Tangential,
So which one will be present?
centripetal.
And what is the formula for centripetal? If you know omega, then how to find AC?
V square by R,
And
omega square R.
so can you find the omega square? Because if you know omega and R is given, can you find the answer?
Yes,
So what was your doubt?
so I wasn't able to figure out the 4 pi part.
Okay, so now I understood I right. Okay.
Yes,
The C1 says that a small sphere of mass 200 gram is attached to an inextensible string of length 130 centimeter, whose upper end is fixed to the ceiling, and the sphere is made to describe a horizontal circle of 50 centimeter. Calculate the time period of this conical pendulum and the tension in the string. Anyway, leave this question. This is all we are going to learn as a theory only.
okay.
Okay, so let's do the practice, and hopefully after practice we will have more insight how to solve. So we did the bicycle problem, right? Turning on a flat road. We have done.
Yes, sir.
So in the question of turning on a flat road, we learned two things. One, that the V max is equals to mu s g r. And second thing, we learned that the tilt of the bicycle with respect to vertical is nothing but the resultant of normal direction and the static friction. And tan theta we got how much? Fs by n. And Fs we got as mv square by r, because Fs is providing the required centripetal force and n is equal to mg, if you remember. And therefore we got tan theta equals to. So when V become maximum, so we can say tan theta max is V max square by Rg. But V max we know is mu s gr. So which is simply mu s. Okay. So if you try to move faster than this particular speed, you need to tilt even more, but the ground will not support and you will skid. So that's dangerous. Okay. So this was the cornering a flat road, right? Or negotiating the flat turn. But human beings are the most ambitious of all species, right? And what we wanted to achieve? Higher speed. So if you want to achieve higher speed, then what you will do? Tell me. To achieve higher speed, what will do? See, if you move faster than this particular speed, you're going to slip. And what we realized in the last lecture, that a normal and MG are of no use. They cannot provide any assistance to turn, right? Do you remember?
Yes, sir.
So to put these forces into use, at least one of them, what we do next is we are going to bank the road. So this is called banking of road. So banking means tilting the one side of the road above the other side. So you can imagine some sort of stadium. I'll draw this. So what I am showing here is a slice of a track. And this kind of track is called the banked track. And you can clearly see, is the track horizontal or tilted?
Tilted.
So if you try to drive your car or maybe bicycle or maybe bike, and if you choose a fixed track, your path will be horizontal or tilted. So imagine one of the dotted lines which I have drawn. If you trace that dotted line, what do you think? Is it horizontal or is it tilted? What do you think, guys? Tell me. These are still horizontal circle, right? Do you realize this? So every person walking on a single track is still moving in a horizontal circle. Do you realize this? Yes or no?
Yes, sir.
So this is the question of horizontal circular motion. So it is just like that the road is tilted. And by virtue of tilting the road, what do we achieve? Any guess? Okay, which force we alter? So out of two contact force, which force will change its direction?
So friction.
And
Normal.
normal. So the contact force will shift, right? So normal will no longer be vertically upward, it will be tilted, right?
Yes.
Yes.
So what we can realize that, okay, I'll draw the cross-sectional view itself, not the entire track. And if I show you this track only sidewise, and because we are studying the particle dynamics, so we are not going to concern about the dimension of the object. So for us, Every object is like a point object. Because if you're actually driving a car, then we have four normal. If you realize that we have uh, two wheels slightly downside, two wheels slightly upside, and everyone is touching at different point of the track. So there are four normal, which we don't consider. And in fact, all those four normals are not equal because they vary in magnitude. And the purpose is to some sort of balance the torque and balance the force both. So when it comes to the rigid body, then we have to actually show the forces in its actuality, in a way, the way it is acting, we have to show. And that will lead to even more complexity, which we will, of course, face in the coming chapter. So as long as we are not kind of approaching this rigid body idea, we are okay, we are safe to consider a body as a point object. The second thing you need to realize that you can choose any height. Okay, you can choose any height for the track which you want to, trace. But your track is not like this. Your track is actually like this. Do you realize this? Your track is here.
Yes, sir.
So this is your track which you are going to eventually kind of circling here. And now this is the circle that we should be concerned about. So when we draw the FBD, the free body diagram, you can say the normal will be acting here. And MG will act downwards. That is well known to you guys. Friction I'll bring later on. But as of now, let's discuss these two forces before we go deeper into the concept. Tell me guys one thing. In the previous case, what was the component of normal here? What was the component of normal in the direction of circle or in the plane of circle? In the plane of circle, what is the component of normal? Any idea? No idea.
So n sin theta.
In the first case, like here,
So 0.
it was 0. Which means normal was not having any contribution to perform this circular motion. But what about this case? Do you think normal is supporting?
Yes, sir.
So do you realize the benefit of banking the road? And if it's yes, then what do you realize? So what do you realize? Do you realize anything? So you should realize that earlier only friction was supporting or providing some centripetal force, but now normal can also do the same, isn't it? Okay.
Yes,
or
sir.
no? All right. So now the idea is normal can also do. Imagine if there is no friction. If there is no friction. So we'll start with the case 1. If mu is 0 between the tire of the car and the surface. Okay. So tell me guys, if mu is 0, then which force will provide the centripetal force here? And we are assuming the car is moving with constant speed. See, you have the ABD in front of you. I'm saying there is no friction. So which force will provide the required centripetal force?
So normal
Normal.
and sin theta.
N sin theta. So this is theta, right? So it is the n sin theta which will provide the required centripetal force. Then who will balance the gravity? Mg.
And cos theta.
Correct. So what I told you in the very first lecture that to solve question, the component of force perpendicular to the plane of motion must be 0. So because if you look at the circle, any force which is normal to the circle must balance each other out. And therefore, this is how we start thinking. So n cos theta is balancing what?
mg.
Mg. So this is the concept which we are using, and concept says that the force perpendicular to the plane of rotation, plane of circle, must be balancing each other out, must be 0. The net value must be 0. That is giving you this answer. And once you come to the circle part, you have to write off the equation net force towards the center is m into AC. And why this so? The answer is obvious. It's a uniform circular motion. So the second part is not at all present, and we should not think about. So, and this will lead to what? N sin theta equals to what? M into V is given to you. So you are moving with constant velocity along this circle. And the radius of the circle is R. Okay. So N sin theta we can write as equals to what? Tell me, guys.
mv square by r.
MV square by R. Very good. So if we divide these two equations, we can get something. Now what we can get? 2 divided by 1 will give you what? Tell me, guys.
Tan theta.
And that is equals to V square by RG. Okay. Is this clear?
Yes.
Yes, sir.
Okay, tell me. The track radius is constant, G is constant, theta is constant or variable?
Constant.
Constant, very good. See, if everything is constant, then V is also constant, right? Which simply means only if the V is equals to RG tan theta, you can move on that track. Okay. So imagine situation. If V Now comes the actual part. So if I create a situation when V exceeds the RG tan theta, what will be the problem here? If V is more than RG tan theta, then what will happen? Or let's say, I'll do this. V is less than, I'll start with the first case. If V is less than RG tan theta, what will happen? Any guess?
So the body will skid or fall.
See, the thing is, the one is the case when things are balanced, right? N cos theta is balancing the mg, right? But n is actually determined by this relation, V. So if I use a, let's say if I use equation 2, n sin theta upon n into R. So basically, when I say V is less than, when you say V is less than under root of RG tan theta, you actually say that V square is less than RG tan theta. So you actually say that NR sin theta by M is less than RG tan theta, right? This is what you're saying indirectly. You know what you say? You say that N is less than mg by cos theta. Do you realize this? And you know what you say? You say that N cos theta is actually less than mg. And now comes the actual part. The one is not valid now, right? It means N cannot balance the gravity. What will happen? If N cos theta is less than mg, what does it mean? The car will start slipping down
Yes,
the
sir.
plane. Do you realize this?
Yes, sir.
Okay, so which means if this is the case, if I choose to say that V is less than RG tan theta, then the N cos theta becomes less than mg. So it will not be sticking to the track, it will start sliding down the track, which is the small track. I mean, it will keep on sliding till it comes to the bottom. Okay. So now, whenever you have V less than this, you cannot stick to the track, rather you will spiral down and will hit the bottom eventually. That's correct. So how to prevent that? Or in a way, if it is more than this, what will happen? So what you can say, that is object will spiral down the track. It is clear? And now if you say similarly, I can say if V is more than RG theta, then So both cases, so in a frictionless inclined track, there is only one particular speed which you can take and move on a fixed track. If it is more or less, it is dangerous. It will go up and down. Okay. Is this clear? Is this clear? Yes or no?
Yes, sir.
You can also realize that as V will increase, N will grow. So a faster moving object will increase the normal. And why this happens? Difficult, it's not very intuitive, but that why when something moves faster will increase the normal. On a curved track, especially on a curved track, why this happens? Any guess? Why faster moving object creates bigger normal? Why? It is difficult, right? Or do you find this intuitive? Anyone knows the answer, like why if I move faster on a curved track, I will feel more normal? I mean, do you have some feeling about it? Some intuition about it? Tell me yes or no. If you don't have intuition, I'll try to create. So no intuition, right? So imagine, okay, this all comes from the concept of inertia. Imagine this is the cross-sectional view of the track. Like if you look from the top, you look like this. And imagine this is the object. And imagine I'm not going this way, I'm going this direction. So you throw this object and it goes here and it makes an impact. Now, faster motion means bigger impact, yes or no? So
Yes.
if you throw something really fast, it will make a bigger impact. And bigger the impact, more the force to apply. It's like greater the momentum transfer. So normal, which is exerted by the wall, will be due to the impact. And this impact will create the normal, which you don't realize. I'll draw a simplified diagram. So as you move faster, the impact will be bigger, and bigger the impact, bigger the force, as we know from the common intuition. So earlier you had no intuition, but you can now realize that why a fast moving object will have more normal, because you make a bigger impact. In a circular motion, you don't move this way, you move point to point. So basically, if I reduce the distance from the between the impact, so you keep on making the impact. How many impact you make? A large number of impact, right? So now imagine you are moving on a polygon of a large number of sides. And if the number of side I will make infinity, then how many impact you will see? You will see infinite impact, which means a moving particle having the inertia to go this way, just to mention. So on a circular track, everything is trying to go this way. But the track is turning, so it will not let you go that way. So it will let you turn. It will kind of come as an obstacle in your path. And so you will hit the new obstacle and will turn a bit. And this collision is so frequent that the interval is almost infinitesimally small. So this is why I have termed this as soft collision, a collision which you don't realize. And it is very counterintuitive that you make collision. So when you are in a path in which you have to keep on turning your direction because of the obstacle, you always hit. And that is why when you move faster, you hit it stronger. And because you hit it stronger, you create a greater normal reaction. If this idea helps you in realizing the normal value, why it is greater. Okay. So you really understand the inertia. Otherwise, take your time to develop this intuition. This is what I can help up to, which you can create the intuition. Otherwise, it's very difficult for people to understand this counterintuitive phenomena, like how normal grows with faster moving object. Do you realize this?
Yes, sir.
And not only this, the faster you move, definitely you increase the normal. But on a rough surface, indirectly, you also change the limiting friction. So a faster moving object actually, helps in growing the value of limiting friction more and more and more. Because the formula is mu(s) into n for the limiting friction. So a larger n will give you the larger range of the limiting friction. And that is how we can actually stand almost vertical on a cylindrical well, which is called the death well because it's a rough surface. And by moving very fast, we create very large normal, which in turn creates very large friction. And that friction becomes even greater than the gravity. So it is very easy. So you create a greater limiting friction, not friction. And because of that greater range of friction, it is capable of balancing the weight of the object, and it looks like it is not falling down. It is moving on a circular track inside the death well. So all the Rambo Jumbo circus, whichever you have heard or might have watched it live, they use a lot of concept of circular motion to show this adventurous stunt. Okay, so of course they use the laws of physics very carefully, but they don't know the laws of physics only, they know how to apply it. And they always maintain a certain velocity. So they never obstruct each other path. They all jump in the air, and they have such a fine-tuned equation that knows that, okay, it will pass the maximum height at this point and this point, this time, and no one will collide. So they practice enough not to make mistake. Sometimes they do, and the accident happens. So all the Rambo Jumbo Circus uses the all concept of mechanics, circular motion, projectile motion, and more specifically the conservation of linear momentum and conservation of angular momentum to show all the tricks. There are many books in called the physics for sports and physics for circus also. So they do read about it. They understand the concept. They do have some technician who helps in setting up the stage, the angle of the ramp, the speed of the bike that they must ride or drive. Everything is pre-calculated to know the exact path, and they do consider certain effect of air resistance, and then they adjust by doing the actual experiment to see how the air resistance is going to affect their calculation, which will definitely not affect much because of the size of the cars are really huge. And after all calculations, when they are done, they start performing the experiment, and with practice, they actually master it, and then it comes in a circus. So circus is a nice place to understand a lot of physics. Anyone gone to watch the circus ever? No one.
Yes.
Oh, you have gone? Prasansa, you have
Yes,
not
I've
gone.
been.
No,
Never
sir.
seen circus? No circus. Oh my God. Okay, so that's why you're struggling with physics, eh? You should go to watch circus sometime. Anyway, the idea is with speed normal changes. I hope you will remember this idea. Okay, so now comes that the benefit of banking. So I can create the frame in this. I can create the what I say centripetal force with the help of normal, which was not doing in case of the flat road, but on a bank road it can. So we have to consider a large variety of parameter here. So let's say we have the bank road, which I will draw the only the angle part, and we do have a circle. So this is the circle, and the center of circle is somewhere here. Okay, and this is your radius, and let me draw the object as a dot. So what we are going to see that without friction we saw the condition, but in real life we do have a friction. So frictionless surface is like if I create a ice skating kind of banked ice skating road, then of course the skaters will have to move only with certain speed if they want to maintain the track. If they slow down, they will slip down, and if they speed up, they will slip upward. So that is also possible. That can be a sport for the next generation. Slightly complicated sport and risky as well, but not at all impossible. It can be done in some cold countries or maybe in artificial state line with sub-zero temperature. But anyway, so before that will happen, let's do it theoretically. And now, if I am saying that the friction is present and not just present, the track is inclined enough. So we are assuming that tan theta is actually more than mu s. Why this assumption? Because we want to exceed the repose so that it will slip. So if the car is not moving, if you do not have velocity, okay. If you do not have velocity, what will happen? Will you have normal, yes or no? And that's very difficult for me. I mean, I'll tell you what is the difficult part. So it is a very common thing that we have done in the laws of motion. When I ask that if normal is, if speed is zero, if there is no velocity at all, the normal, we should take this component or this component. I mean, the actual direction or the vertical component normal. Should we resolve the normal or should we resolve the mg? In laws of motion, what you used to do? Do you remember? In laws of motion, you used to write n equals to mg cos theta, right?
Yes.
You might remember. This way of solving is okay if we are dealing the object moving in this direction or this direction. But our track, what I have shown is not the inclined plane. It is a circular track. with banked, cross-sectional view. And that is why it is sometimes counterintuitive to solve the way I'm saying. They take this normal into component for balancing mg, not this way. So this is the wrong way if you are having some velocity. So you need to realize that this diagram is not motion on inclined plane. Is it so?
No, sir.
That's why this kind of diagram, which you will tempted to draw, but will give you wrong answer. So whenever you are solving question of circular motion, do not get tempted by the inclined plane ABD, which generally it happens with many students. They do the same thing always. Okay, anyway. So our case is simple. The tan theta is more than mu, so it will have the tendency to slip down the plane. Okay. The first thing first. But with some velocity, some speed, you may increase the normal. Okay. You may increase the normal. But if there is if there is no velocity, then you are having tendency to go down, right? Correct? So with zero velocity, what is your tendency? To slip down the track, yes or no?
Yes, sir.
Given this condition, with zero velocity, your tendency to go down the plane.
Yes, sir.
When v is zero, the n is actually mg cos theta. But when v is non-zero and it is not slipping, then n is actually mg by cos theta. That's very interesting.
Yes, sir.
But with friction, things will change. It will not be similar answer. So we have to go very deeper and slowly try to understand what I'm going to explain. So the first thing first, we are going to deal with two extreme situations called V minimum and the V maximum. We know that it will slip downward. So what is the minimum V which can prevent the slipping? I need V minimum. So when you try to solve for the V minimum, the tendency of the object will be to slip down or slip up. What do you think? What will be the tendency, guys? To go down the track or to go up the track?
Down the track.
And because the tendency is known to you, how the friction will act?
Up the track.
Very good. So when we are solving for the V minimum, the Fs will act like this. But we are solving for the V minimum. So we believe that the friction has reached the limiting case in order to stop it, because we want to calculate what is the least V. We know that friction is not sufficient to stop it. So you need to grow the normal by moving, and we would like to calculate what is the minimum V that is sufficient to just hold it there. And that is what we are going to solve. The concept is clear.
Yes, sir.
Okay. Now these two forces can be replaced by the normal and friction, because friction is going to be mu into n in this case. This is a shorter version of solving. The two forces can be replaced by one single force, right? And tell me, the single force will be inclined vertically left or vertically right? This way or this way? What do you think? Any guess? This way or this way? So first you guess and tell me why. Why you are guessing that way?
So it has to be close to n. No.
Very good. You know why it should be close to n? Any guess? Because the same force has to provide the centripetal and balance the gravity also, right? See, gravity will never ever provide the centripetal force. This is clear? I hope so. So the obvious
Yes, sir.
question is then who can provide? So it is the surface contact
Normal.
force. No, don't say normal and friction. We are replacing by the single force, the surface contact force. So we can say when you keep something on a surface, it will have only two forces. The reaction force due to surface and the gravity, right?
Yes.
And the reaction force due to surface we resolve into two parts, like the way you know. This is theta, this is also theta. So this is how much? 90 minus theta, right? Okay. Anyway, this is theta entire thing. This is theta, right? The entire angle.
Yes, sir.
And this angle you can take as alpha. By doing so, I will tell you first of all. The alpha is known to us. What is tan alpha, if you remember? Tan alpha is how much? Mu s n by n. Anyone realizes tan alpha is in this mu s? Hello, hello, hello.
Yes,
The
sir.
resultant of normal and mu s n. So we know this from the friction chapter, right? In the limiting case, tan of angle made by the resultant with normal is always mu s, right?
Yes, sir.
So how many of you remember this fact? Roshan sir, do you remember this? No. Whenever we have the Fs max, which is mu s into n, and whenever we have normal, the resultant will make how much angle? So tan alpha is how much? This upon this, right? Which is mu s n upon, or Fs max upon n, correct? Do you remember this? Yes or no?
Yes. Sir.
No, you don't remember. Okay, if you remember, do you realize now what I did?
Yes.
So can you use this realization later on in future?
Yes. Sir.
Okay. So let me know this. So because we know tan alpha is mu s, okay, what we should write? I mean, that's very easy. We know we have to balance the gravity, which is mg force. So what we can write? R cos. Tell me. Which component of R will balance mg? R cos? No
R
idea.
cos alpha.
Huh?
R cos theta.
R cos? Theta is the entire angle from here to here.
Sorry, theta minus alpha.
Actually, theta minus alpha. This will balance the mg. And what else? R. If cos will balance the mg, then sin will provide the centripetal force. Yes or no?
Yes, sir.
So
Got it.
we are simply resolving R into two components, and this will make things really, really easy. And you can see that without writing so many questions, we can solve in one line. So what we can write here is 2 divided by 1 implies tan theta minus alpha is how much? V square by RG. So answer is very simple. V square is RG tan theta minus alpha. What is the difference from the previous question to this question? The tan theta got replaced by theta minus alpha, right? And this is called the V minimum case, right? Which is under root of RG tan. But generally, you will not find the answer written this particular way in books. They write in a different way, and how they write, we can simply expand this tan A minus B formula. What is the formula of tan A minus B? Tan A minus tan B upon 1 plus tan A.
Tan A, tan B.
Very good. But we know that, what we know? Tan alpha we can replace by what? Mu S, correct? And this is the formula which you will see in textbook. The way we solve is very easy. I'll show you the difficult method. This is the method 1. So if you really understand the concept of friction, I mean the surface contact force, then you will be saving yourself from the rigorous calculation. It's very one-line answer. And it's easy to remember. It is always RG tan theta, but for minimum, write theta minus alpha. It's very simple to remember, right? So because we have seen the calculation, right? If mu is 0, the alpha is also 0, which will give you the answer which we have obtained earlier, right? Yeah. You can see here. So without friction, what was the answer? RG tan theta. Now what is the answer? RG tan theta minus alpha, right? Is this clear?
Yes,
Hello, hello, hello. What will be the other method? Like, the other method is not difficult. Just you have to write in terms of N and friction instead of writing in terms of R. So let's say if you are not comfortable with that, you should be actually, because I have experienced so many times this concept that you should be comfortable. But still, if this doesn't click you, we do have one alternative method, which I don't like at all. But when I learned for the first time, this is what I was knowing. And then one fine day I realized this could be solved this way. And life changed. So if you draw the ABD again, you have normal. And now I'm not going to talk about the R vector, the resultant. And we are going to solve only for the limiting case when V is V minimum. And this will be the ABD, the free body diagram. Okay, just. So you can clearly see here, if you don't use R, what will happen? You have to resolve both the forces, isn't it? In which direction? So mg is going to be balanced by which forces? Tell me, who will balance mg now here? Who will balance mg? Tell me, guys.
normal and FS.
Normal and Fs max, right?
Yes, sir.
So how you're going to balance the force mg? What will write here?
N cos theta plus mu s n sin theta.
Very good. So I can take n common. Cos theta plus mu s sin theta, right? This is what you said, right?
Yes, sir.
And this will balance mg. So you have balanced the force acting perpendicular to the plane of circle. And what is the next concept which we discussed? The net force towards the center will provide the required centripetal force. Then what you will write in this expression? What to be substituted?
N sin theta minus mu s n cos theta.
N sin theta minus mu s n cos theta, right?
Yes, sir.
And this must be equals to what? mv square by r. Is this clear? Why I'm writing
Yes,
this?
sir.
And you can see the n can be expressed into two ways in this particular situation. So to get rid of n, because we do not want n, what we want here is the minimum speed. So what we'll do next is you can just divide the equation 3 divided by 1. And if you divide, it's also easy, only not very difficult. The v square by rg turns out to be how much, guys? It is sine theta minus mu s cos theta upon cos theta plus mu s sine theta, which you can take cos theta common, so it will come tan theta minus mu s, or you can simply divide by cos theta numerator and denominator will get 1 plus. See, similar answer, right? The minimum turns out to be how much? Rg multiplied by so, well, this is also easy only. I won't say this is difficult, but that is like some elegant way of solving. So I call that as elegant solution. This is a solution by component, which is trivial solution, but not elegant. Okay. So you have the answer for the situation before. And now tell me, what will happen if I ask you, what is the maximum speed possible? What will be the modus operandi to solve for Vmax? How the FBD will change? So if you try to drive really fast, what will be the tendency to go up or to go down?
So to go up.
And therefore, what will change the direction? Which force? So which force will switch the direction? mg can't switch, normal can't change. What will change?
Friction.
So friction will act down the plane or up the plane?
Down the plane.
Down the plane.
Very good. So the alpha which it was making on the right of normal, the same alpha it will make now?
Left
Up
of normal.
So can you draw the entire diagram and solve by the method 1 and also solve by the method 2 and show it to me? So you all have to solve by both the method, the elegant and the trivial, and show it to me. Send to me on my WhatsApp. I'll check and then we'll move forward. Do it, guys. I'm giving you 6 minutes to do the same. So once done, if you're done with the first method, send it to me. Meanwhile, I'll check the first, you can do the second.
So can you please show the first and the second method ones?
So you are supposed to draw the ABD correctly. And the next step is think about the circle. The next step
Sir, I
is
haven't written down the first and the second.
doesn't
one,
matter.
sir.
Doesn't matter why you want to write the method to create the other answer. Can you arrive at the answer through the logic, through the concept which you have learned? Not because you have seen the answer somewhere, so you can just replicate the method. Think hard, think hard. I mean, you're still not pushing your brain to think. You're trying to kind of copy and paste and do some cosmetic changes in the way things are written, and you know that you will get the answer. I know what you're trying to achieve, but that will not help. Siddhant, you got the answer?
So 2 minutes.
Okay. So why you need those answers? I don't think so. You need any answer. The moment you see, you know what to be done. But if you really think hard and arrive at the answer, that will change your thinking forever. So what do you want? The easy one or the difficult one? Still want to see the answer?
No, sir.
Good. Okay, nothing. Very good. So that's correct answer. Siddhant. And what we'll do next is you will expand the formula and substitute 10 alpha as what? Siddhant. So what we're going to do next?
Tan alpha as mu s.
Very good. So do the needful and also try the trivial method, the compound method by drawing the ABT again. Okay, tell me, Prashant, sir, you got the answer?
No, sir, I'm still trying.
Are you able to draw the FBD free body diagram? Do you realize the circle and how to resolve the forces? What are the concepts in which we progress to get the answer? What we do exactly? If you have doubt in any of these, you can ask.
So I've drawn the FBD, but I don't know how to proceed after.
Okay, show me the evidence. Send me. Let me see it first. Okay. So what is the concept? Like how we solve question? You have the ability. The first thing is all the force normal to the circle must be balancing out each other.
Yes, sir.
So if what are the forces balancing here? And if you want to solve in terms of capital R, then which forces should not be considered? R represents which force? Okay, you don't know what is
So
R,
your
right?
n cos theta will balance mg.
No, you're not getting the point. If you are drawing the R in your FBD, then which force you should not draw? Or you should not consider while solving. If you want to solve something in terms of R, then which forces should not be considered? We have no clue about it. Yes or no?
Yes, sir.
But what is R then? Why you have drawn R at all? Tell me. Come on, what is R? If you don't know, then let me know. That's I don't know what is R. You don't know what is R?
No, sir.
Then why did you ask when I was explaining R there? Like why you learn the way you learn? I mean, it's ridiculous. You don't know something, still you proceed. So R is called the surface contact force, which is the resultant of normal and friction both. So when you consider R as a force, then N and Fs max should not be considered. So either you use R and solve the question, or remove R and use N and Fs max separately. Is this clear?
Yes, sir.
So what R represents?
The surface contact force, which is the resultant between normal and Fs max.
And what is alpha representing?
Angle between the normal and R.
And how much is that angle? What is tan of that angle?
Fs max by n.
Now, what is Fs max formula?
Mu s into n.
So what is tan alpha now?
Mu s into n by n, which is mu s.
So tan alpha is how much?
Mu s.
In which case, when Fs is Fs max. So in the
Yeah.
limiting friction case, the tan alpha is always mu s, right?
Yes, sir.
So what you are going to balance first? When you solve a question of circular motion, the horizontal circular motion, then what we should balance? Which force must be balanced out each other? Tell me which force we should balance out each other.
So the force perpendicular to the plane of the circle.
So what's the problem? Why I'm not able to do this? Oh, because you were not knowing what is R, right?
Yes, sir.
And because you were not knowing the R, you never asked also. Hmm. Yeah, Siddhant, both methods are absolutely correct. Wonderful. So you can post in group as well.
Fine, sir.
Post in group. So tell me, Prashansa, how many hours are you studying? Or you are living a normal regular life? Tell me. I don't think you are studying what it takes to be a good JEE aspirant. You're trying to live life more than studying it. You want to enjoy with your friends more often than before. Seems like you don't have a goal. You just want to do this routine job of preparing for competition. This is not what you want to, right? You want to just pass the examination and feel happy about it. Is this your goal? Tell me.
No, sir.
Oh, be honest. See, there is no problem. This could be a goal. There is no issue about it. That's totally okay. Hmm. Okay, so I think Siddhant has posted the answer. You can watch the answer. Can you read the answer? You can understand. So I'll just mention this answer here. So quickly, I'll draw the diagram also. Okay, anyway, see, life is all about happiness. So if you're happy by not studying, I'm known to say that you should study. But please don't ask why you didn't qualify in certain examination. And don't expect anything from you also. Happiness is very, very important. So if you choose the first elegant method, first of all, this angle is always theta. And the resultant that the R will make with vertical, I can just do the way I will. This is alpha, this is R. So definitely R cos theta plus alpha will balance the mg and R sin theta plus alpha will give you the required centripetal force, and that's where it's very easy. The V square is Rg tan theta plus alpha, and we know this is V max. So V max is under root of Rg tan theta plus alpha, which will give you eventually answer as Rg tan theta plus mu s 1 minus mu s tan theta. So case 3, this will be case 3, I think. This is case 2. For V minimum and method 2 on your own. Okay. So I hope this is clear. Tell me guys, is this clear to you guys? Yes or no?
Yes.
So these are the very standard practice questions, banking of road, in which they will ask you the extreme case, the minimum and the maximum. Definitely they will not ask you in between, because that is something which you can't solve method. You can just have the extreme answer. So be ready. Questions like this can be asked. Okay. I hope this is clear to you guys.
Yes.
So next is the concept, which is again very famous, which is also part of the horizontal circular motion, is called conical pendulum. So of course, there is a history behind this particular topic, and the history is as interesting as this topic. Although mathematically it's a very simple thing, but looking from the historical point of view will give you the real sense of this particular problem. So among philosophers, I mean, of course, people were knowing from the long time that the Earth is rotating, but the question was how to prove that Earth is rotating. Let's say if I ask you that Earth is rotating, you know as a fact. But if I ask you, can you prove it? What you will do? Tell me what will do. If I ask you prove that Earth is rotating, how are you going to prove indirectly? Okay, no idea. Neither. So this idea was actually used to understand the Earth's rotation. And in fact, for the same idea, the understanding of the planetary motion. So what they did? So it's a very famous legend that from the Leaning Tower of Pisa, they suspended a pendulum and they simply left. So in your household, if you suspend a pendulum, what you will see? Is stationary or moving? You simply suspend something from your hand using a thread. Do you see it to be moving or do you see it to be at rest? What do you see in your day-to-day life experience? Okay, you don't have any experience?
Some moving.
You see moving. Your hand must be vibrating or maybe shivering. Technically, if you lift something, it will be at rest, isn't it?
Yes.
So it will try to move, but the thing is, it will create a circle of almost insignificant radius. So you won't be able to, sorry, feel the rotation. But when the same bob is suspended from the very tall height, like the tip of the Leaning Tower of Pisa. What do you call Pisa? How you say? Pisa is correct way of saying? I don't know. So these are Italian words, so maybe I may be wrong. So when you suspend, then the tip of the tower is not at rest because the earth is rotating. And as the earth will rotate, what will happen? The tip will also rotate. But the question is, can we see the tip to be rotating? Yes or no? So imagine this is the tower and this is the pendulum. This is the earth. But as Earth will rotate in a way, you can think that this tip will also rotate, right? Isn't it? So as Earth will rotate with omega, the tip will also turn with omega, correct? And tip will move in which path? The tip will move in a circular path, isn't it? Hello, hello, hello. Hello, hello, hello. Yes or no?
Yes, sir.
But every observer sitting or standing on the earth cannot see the tip to be moving, right? For you, the tip is at rest. You know what will happen? For the person, instead of the tip, you will end up observing the pendulum to be moving in a circle. And this is, of course, the centrifugal force, which you can name it, but the suspended pendulum will actually trace a cone. If you look in that perspective, it's like a conical, that's why the name is conical pendulum. So it is like you take at the tip of the pendulum and you start rotating in a circle. So in the frame of Earth, the tip is not rotating, rather the pendulum is rotating. The idea is the tip is turning. That's very interesting. And whenever they suspended, they realize that the bob eventually is set into rotation with a fixed time period. And actually that time period was same as that of the Earth. So that is how we actually calculated the Earth's orbit, Earth's angular velocity. Because of course you can't see how fast the Earth is spinning, but the history of conical pendulum is that it is the conical pendulum with the help of which various physicists like the Robert Hooke or Christian Huygens, they actually realized this that the Earth is rotating with constant speed, constant velocity, you can say angular velocity, and it was a method to determine the same. But now today we are studying as conical pendulum. So that is the history, and if you think from that perspective, it's one of the most remarkable and elegant experiment to get this answer right. So in real life, there are various indirect measurement, and knowing the concept and the relation, we can always infer something which is very really mysterious in a very simplified and simplest way, or you can say elegant way. So that is the history of conical pendulum for you. In that case, we assume the tip of the pendulum to be a fixed point, and we assume the bobs to be spinning on a circular track. So the mass, the moving mass, if you only concentrate on the moving part of the pendulum, it will trace a horizontal circle. Do you realize this? Yes or no?
Yes.
So don't look at the bob, look at the mass, the moving mass. And if you look at the moving mass, you can clearly realize that it is tracing a horizontal circle, right? And not only this, the angular velocity of this rotation we are going to assume as omega, which is constant. Okay, so we assume that it is turning with constant angular velocity omega. And it will always look some angle away from the. So the question was, see what we can observe. The L can be measured by the scale, right? By a ruler, correct? And theta is also experimentally verifiable quantity. We can always calculate theta by physically looking at the pendulum. Yes or no?
Yes, sir.
So because you know L, you know theta, so you can also calculate R from geometry. What is R? In terms of L and theta, R is
L sin theta.
and I hope you can draw the FBD. Whether you know physics or not, you can draw the FBD. So if you know the basic laws of motion, can you do the ABD? Hello. Tell me, guys. So what are the forces acting on this moving mass, the bob? Tell me. Hello.
So tension and gravity.
Very good. So gravity will act vertically downward, and tension will act towards the point of suspension. This is called point of suspension. So tell me, guys, which force will balance out each other and which force will provide the required centripetal force? I think that's very obvious. So do you see the center of circle? Hello. Do you see the center of circle? Do you see the center of circle? Do you see?
Yes, sir.
So what is the force acting towards the center? Okay, first of all, which force will balance out each other? So because your circle is horizontal, so the method one is the net force in the vertical direction is balanced. Let's this is y. So can we say the net vertical force is balanced? And if we can say, then what we will write here?
T cos theta equals to mg.
Very good. I don't see any difficulty here because I see the circle first. See, the rule is if you want to solve question of circular motion, the first thing that should click to your brain is the circle and its plane. And if you cannot see it, I'm sorry, you won't be able to solve this question. And for that matter, any question of circular motion. So always listen carefully what should be remembered. You're not supposed to mug up everything. So T cos theta equals to mg. That's correct. What else I will write? Once you balance the force, once the angular speed is constant, so the next equation will be coming from where?
So T sin theta is equal to mv square.
mv square. What? mv square. Is
Sorry,
that the formula?
mv square by r.
mv square by. So write down. So T sin theta is m, but we were not going to use the v square, though we can use, but because omega is given, we should use omega. So what do we write in terms of omega?
T sin theta equals to m omega square into r.
Into R. So can you solve for omega? I want the omega answer. Can you solve for the omega? Can you solve for the omega? Tell me.
So omega is under root g tan theta by r.
Omega is under root of G.
Tan theta by R.
So which is the root of G by L cos theta.
Correct. So R we can replace by L sin theta, right? So this is the right answer, G by L cos theta. Okay. And now I'll try to draw your attention towards something really crucial here. And I would like to introduce a new term called H. And the H is nothing but L cos theta. Do you realize this? Hello, 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 hello.
So it should be G by L sin theta, right?
G by L sin theta. Why L sin theta?
Because R is L sin theta.
But tan theta is sin by cos.
Oh, yes, sir.
So sin will get cancelled. Correct?
Yes, sir, got it.
All right. So this answer is best expressed by writing G by H under root. And that gives you the sense that it is the distance between the H is the distance between the point of suspension and the center of the circle. And therefore the time period is defined as 2 pi by omega. So you can write as 2 pi under root H by G. Okay. And that is something really interesting. So the time period really depending on the separation between the point of suspension and the center of circle, right? Hello, hello, hello. Hello, 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 hello.
Yes, sir.
Okay. Now, I don't know if you have gone to something like a SL World or maybe some amusement park in which there is a like hanging horse ride. Have you experienced that hanging horse ride in your childhood? So there is a wooden horse on which you will sit, and it is attached to a rod. And then they start turning, and then all the horse will fly away, right? Anyone who has experienced this? No one. For sure. Any? You don't have any childhood memories? Okay, you don't have. No real life, only virtual life, no? Okay. Hmm. So this is the very famous kind of thing. Okay, I'll send you some photographs. Maybe you can realize in your life. Okay, here we go. This is the hanging horse rider. Do you realize this now? Okay, you can see the WhatsApp I have sent. Tell me, do you realize this now? Yes or no?
Yes, sir.
Anyone has seen this before? Like experienced this before? No
Yes, sir.
experience. Uh-huh. Really bad. Okay. So this is called carousel horse. Okay. Anyway. The whole idea is it is attached to a rod or a rope, and when they start the ceiling is fixed with all these ropes. So as the ceiling starts rotating with omega, the horse will sway away from the center and will become a conical pendulum in its own. That is the whole idea. So what I wanted to prove, this one. Look at this, what I'm trying to prove here. A life experience. See, physics is everywhere. The only thing is you have to start observing. I don't know when you will start, but someday you should start. So you can see we have three strings of length L1, L2, L3, and definitely all are making different angle with vertical. So it is like a horse ride with three different horses attached at the end of this these pendulums. And for simplicity, I have fixed at the same point. You can change it as well, but right now we have fixed to the same point. And what you can realize, or you should realize, that all are having horizontal circle in the same plane. Do you realize this? They are having same plane? Maybe. And not only this, you can also realize that the center is, these are concentric circle and the height is same. So although the angles are different, lengths are different, will they have different time period or same time period?
So different.
So they will have the same time period. The reason is all are having the same height h. Which means if you are, if it is a motor driven kind of arrangement, I can fix omega. So they will like swing in a way to reach the same height. So for a given omega, they will attain the same height. Okay. So as L will change, theta will change, but in a way that the h remains same, because they all have to be in the same height. Is this clear?
Yes, sir.
No. Okay, fair enough. So they will ask you what is the time period relation. If I say the time period is T1, T2, and T3, all are going to be equal, because the formula for time period is how much? G by H. Sorry, H by G. Yeah. So time period is 2.0 H by G. Correct? So how to answer the question? If you see that height is same, it means the L cos theta will be same for all, and because L cos theta is same for all, so it means they will have same omega and same time period. Okay. This is a very important concept from the conical pendulum. So what else they can ask? They can ask you the tension value. So T equals to mg by cos theta if it is horizontal circle. And they can ask you time period relation and so on. So these are simple diagrams. Just draw it and solve it. Okay. So we are done with the conical pendulum. So we are going to the next concept, which is circular motion, which is uniform circular motion, but we are going to make some changes. It's called the uniform circular motion in a vertical plane. So uniform circular motion in vertical plane. Okay. So tell me some example in which you might have experienced something like this. Let's not call circular motion, you can say uniform curvilinear motion in vertical plane. Have you any experienced the uniform curvilinear motion in vertical plane? And if yes, then when you experienced this or where? Where generally we come across such situation in our real life?
Sir, on roller coasters.
A roller coaster. Yeah, that's correct. So that's even more interesting. But in roller coaster, do you think it's a uniform speed or they keep on changing? The thrill comes because of the random speed or constant speed.
Random speeds.
It means it goes up, goes down, right? You have acceleration suddenly and then slow down.
Yes, sir.
Then so I think roller coaster ride is a very good example of non-uniform. You can say vertical motion. So I'll tell you like where you can.
So giant wheel.
Giant wheel, yeah, that is there. So giant wheel is vertical motion in which they keep on turning it with constant omega because it's eventually motor driven. Yeah, so that is possible. Yeah, that's possible. So the London side or giant wheel, and giant wheel is not only in London, you can see anywhere. Even in the local Rainbow Circus, we also have this wheel. So the idea is, if I talk about the day-to-day life, when you commute and you cross the bridges, which we call flyover or over bridges. So you must have seen that it starts from the level of the road, it goes up and comes down. Do you realize this? And you might be driving your bike or car. Correct? So technically, it is a curve in shape, but we can also make it more interesting by assuming it to be a part of a circle. Can we assume? Part of a circle?
Yes, sir.
And also because we are driving or riding, we can control the speed, yes or no? So in a car, can we control the speed?
Yes, sir.
All right. And if you can control the speed, what you should realize that it is the example of uniform motion on a vertical plane. I mean, in a vertical plane. So these overbridge or the bridge problem will be part of such situation. And we are going to discuss the uniform speed case, uniform motion case, because the person who is driving will try to maintain the speed. And that is what we are going to see here. Okay. So uniform circular motion in vertical plane is a typical day-to-day life experience. And every time we are crossing the bridge, or sometime you also go in a ditch. So if there's a giant ditch which you come across, it is also, it could be a vertical circular motion. But generally in ditches, you accelerate. Okay. You can speed up. You can maintain the speed also. But that's a bad experience because we don't want ditch on a road. Okay. So to make it simple, okay, to understand the basic, what we are going to learn is the uniform one, right? So, this is the arc of the overbridge. Of course, you will not see the entire thing. I'll just try to cover the part which you will not have access to. And the road will start from this level and it will end here. And just to emphasize the fact that the arc you're going to trace is a part of some circle, I have also drawn the circle. But your journey will be only on this highlighted part. And also we are assuming the radius of curvature of the bridges to be large enough such that the vehicle can be considered as a point object. So at any instant, the vehicle is only at a point of this track. So let me do the entire diagram. Okay. So I'll keep it alpha. So I'll keep it symmetrical alpha, and also, as I said, the objects we are going to consider will be like a particle. So we will not worry much about the size or the dimension of the vehicle. Also, we will not assume any bump during the climbing or when you get onto the flower and when you get off the flower. We are assuming this to be a transition which is really seamless and smooth. So all these things are under the assumption. And now the particle which is going to trace this track will be moving with constant speed. So here we have the uniform, so V is going to be constant. Okay. So it could be convex. You can also create a concave kind of the ditch kind of shape, and you can do the similar analysis for the force and everything else. So how to go about it? So what I'll do is I'll take some random location for the driver. And as a very common practice, this practice is what everyone uses. So you should also learn this practice, that when you're solving a vertical motion, okay, and if it is a symmetrical path, as you can see with respect to vertical, the variable should be taken from vertical itself. So I'll take the theta from here. It's a common practice. Always take the variable. So alpha is the finite angle for the entire track from the beginning and the end of the track. And theta is in general, which I assume with respect to vertical, not horizontal. And this is my object. So as usual, I will draw the object like a dot, a slightly bigger dot for emphasizing this is the object. The next step is going to be what? What we do every time? If you want to solve question of a circular motion, what you will do? Hello.
Draw the free body diagram.
Very good. So you guys are expert. Can you draw the ABD now? Can you draw the ABD now? Hello. Tell me yes or no. So you all have drawn the ABD? Do it quickly, fast. So I believe that you all have done this ABD. Should I believe?
Yes, sir.
No. So for any circular path, it's very easy to draw the normal. Normal is going to be along the radial direction. Have you done normal like this? Yes or no?
Yes.
Listen, so how you drew the normal? Like this or like this? The way I did.
So the way you did.
Are you sure?
Yes, sure.
Okay, what other force you can think of? Apart from normal, which other force will act here?
Sir, MG.
MG. Okay, let me go. So MG will act like this. I hope so. This is clear to all of you. So MG will have two components. This is also theta. So MG will have two components. One towards the center. How much? Towards the center will be how much?
mg cos theta.
But one will be along the tangent, right? How much? Mg sin theta. And we know that the speed is like this. And we know V is constant. So the net tangential force should be 0 or non-zero. So constant speed tangential acceleration is 0, right? I hope you remember this.
Yes, sir.
So how to make the net force 0 along the tangent? Do we need to bring some new force? Or this ABD is sufficient? Right now, what is the net tangential force? Okay, you don't understand the tangential force,
MG
right?
sin theta.
Very good. But to move with constant velocity, the net tangential force should be 0, no?
Yes, sir.
So who will make
Yes,
this
sir,
force 0?
opposing.
It is only possible if we can bring some friction. In which direction? So what are the equations? First of all, do you realize the circle, the plane of circle?
Yes, sir.
Okay, very good. So you realize the plane of circle. That's great. So do we need to think about the forces normal to the plane of circle? Hello, hello, hello.
Yes, sir.
You have to tell me which force you think is normal to the plane. The circle itself is vertical, so normal will be horizontal.
Okay, fine. Yes, sir.
So you got the idea, right? There is no force acting normal to the plane. Do you realize this?
Yes, sir. Because V is constant.
So, because V is not constant, because normal to the plane is this way, right? Towards you or away from you. And we don't see any force either towards me or away from me. So that part is gone. The forces normal to the plane is absent at all. So no need to think about it. So we have to only think about the two equations. The net force towards the tangent should be 0 because AT is 0 because and the net force towards the center equals to mv square by r. That's very easy, no? Is it difficult to apply? Okay, if you realize, then let me know. I'm waiting for your answer.
Yes, sir.
Prashansa and Siddhant, do you realize this?
Yes, sir.
Yes, sir.
Why so feeble sound? Do you really realize this?
Yes, sir.
Good.
Yes.
So explain question. So what I will write for the first part? What I should write here?
So mg sin theta is equal to
Fs is equals to mp sin theta. So the theta is variable or constant? Hello.
It's a variable.
Let's plot the graph first. So if you start from the left side of the flower and if you end at B, so from what angle you start with? What is the value of theta when you start? Okay, by the how the graph of sin theta will look like in the first quadrant? Like this. Okay. Not okay. But our graph is from where to where? So when theta is 0, theta is 0 means we are where? You are at the topmost point.
Yes.
So basically, I should do something like this. So theta is actually from minus alpha to plus alpha. Minus alpha to plus alpha, right? So if I take this as a reference, then theta will vary from where to where? This is what you have to realize first. So the graph will look like this. Alpha is less than 90, so alpha is somewhere here. So your graph will be only up to this value. Let me make it bold. So the Fs will vary from minus alpha to plus alpha. Is this clear? Is this clear? Tell me.
Yes.
So at which point we do not need friction? At which point? At the topmost point, right? Because at the topmost point, the gravity will have no component along the tangent, isn't it?
Yes, sir.
And where we need the maximum friction? So where we need the maximum friction? Near the edge A and B. Do you realize this? So at A, the slope is maximum, right? Mg will have maximum effect down the plane.
Yes, sir.
So at A, the Fs will be maximum. So to move from A to B without slipping, what is the maximum friction we need? So maximum friction force that we need to go from A to B without slipping anywhere. If we will not slip at A, then we will not slip anywhere, right? The maximum tendency to slip is at which point?
A and B.
A and B. So if I can prevent the sleeping at A or B, then we are not going to sleep anywhere else. Yes or no?
Yes, sir.
Very. So this is the note which you must remember. Let's type it. So to cross the bridge without sleeping, the minimum minimum. Okay. That is the note actually. Generally, this is what asked in the examination or in the question or in the challenging problem of circular motion. So all the most challenging problem of circular motion will be from this particular concept. Anyway, so you write the equation Fs equals to mg sin theta and the second question we didn't write. Okay. So this will lead to what equation? Tell me, guys. Hello. Am I
Sir,
audible,
mg
guys?
cos theta minus n.
Very good. Mg cos theta minus n. That is equals to how much? M.
Mv square by r.
So do you guys realize this? Yes or no? Yeah, tell me, person, sir. Do you realize this?
Yes, sir.
What? Yes, sir. What happened to you? No energy? Go have something, okay? Eat something. Speak loudly. See, I'm not forcing you to answer. I'm saying that okay, if you're not understanding, you can ask. And that sound is saying that you're not putting the right effort. That's for sure. Okay. So the one is the condition to have zero tangential accretion, and two is the condition to have the circular motion. Very good. So now two implies what is n? N is how much? Mg cos theta minus mv square by r, right? Mg cos theta minus. So the n is m common g cos theta. Okay. So what is the, because second term is kind of constant, this term is constant. So n will be maximum when theta is
Maximum.
theta is minimum. Cos is the decreasing function.
Okay, got it.
The second term is constant. The first term is cos theta. So for n to be maximum, the theta should be minimum, which means which point? So at topmost point, the theta is how much? 0 degree.
0. Yes,
So n will be what? Maximum or minimum?
maximum.
So we'll get the maximum normal. So the maximum normal we get is m g minus v square by r. This is the maximum normal. Good. Okay, so at A or B, what is n? So at A or B, the theta is maximum. N will be.
Yes, sir. So minimum.
So you have to deal with the least normal at these points, which is logical because on a slope we don't get much normal. So the minimum will be n cos g equals to alpha minus v square by r, right? All right. So now they will ask you, find mu minimum for safe journey over bridge. Let's call this is over bridge. So for safe journey, what is the minimum mu which I need to have? If you remember, you need maximum friction at the A or B, right?
Yes,
So Fs max is going to be how much? Like not Fs max, it's like the minimum friction that we need is how much? The minimum friction that we need. The worst case scenario we have to deal with safely. So we know that if Fs required to move safely, yes, safely means without slipping, that's it.
this has to be maximum. No? If
Yeah,
it's
this
max.
has to be maximum, which is mg. What was that? Was sine. Mg sine
Sin theta.
alpha. So it becomes sine alpha, right?
Yes,
And to have the mu minimum, this should be equals to Fs max. So the minimum force required of friction is actually the limiting friction of that point, because we want to make it mu minimum, right? Therefore, the mu into n minimum must be equals to mg sin alpha. This is
yes, sir.
kind of confusing. See, the minimum friction for the journey is the maximum friction for the end point in order to have the minimum mu. I mean, it's like, the limiting case is achieved. So that's why the formula is mu minimum into n minimum. What is n minimum? N minimum is mg cos alpha minus
MV square by R.
mv square, and this is equals to mg sin alpha. So m gets cancelled, and that gives you the answer on the next page. That's why I said this is the most challenging problem. So what we are going to get here is that mu minimum into g cos alpha minus v square by r equals to g sin alpha, right? This is what you got. So mu minimum is how much? G sin alpha upon And this we can write as 1 upon tan alpha minus it looks, I don't know, good or bad, but and to have the meaningful answer, it should be positive answer, right? So for meaningful answer, that tan alpha should be more than that's it, which means something like this weird. So you cannot move really fast. You know why? Because if you move really fast, you will leave the track. You will go off the track. That's the problem. So generally what they ask this part. You can leave the answer the way you want. And you must practice and realize what I did here. It's not very simple. It's not intuitive also. So you have to work hard enough to understand what is the intuition behind solving such problems. Is this clear?
Yes, sir.
All right. So now we are done with the uniform motion. And from the next lecture onwards, I'm going to start the non-uniform horizontal motion. Okay. So the motion is so far uniform. We have written the equation. Your homework will be slightly more now. So your homework is from the SC Verma. So that is the finest book for this particular chapter.
So can you please go to the previous page once?
Yes, I'm going to share you. I'm going to share this PDF just. Okay. So homework is HCV. So from HCV, you can try up to 27. 1 up to or 1 to 27. So solve or try these questions. In between, you will get some question of variable circular motion, but that you can also attempt it because you know the method. And the last 3-4 questions are called the centrifugal question, like concept of centrifugal force. So that I will explain separately in the next lecture. Hopefully, by next lecture, your chapter will be over. So your next lecture will be on Friday. And I will also try to keep lecture on Saturday or Sunday. So from this month, let's try to keep 3 lectures a week as and when possible. So you all can, be ready for at least Sunday, Saturday. Give me at least 2 hours in the afternoon time. That is the best time. Or if you want, morning is also possible. So if you want in the early morning to afternoon, so that you can free in the afternoon, beyond afternoon, you can do things with what you want.